Hi, in this lesson we're going to use algebra tiles to solve one-step equations such as x plus 4 equals negative 3 and a minus 7 equals 4. In order to do that, to begin with, we're going to start out with a t, which you can make just on a regular sheet of paper. And we're going to start out by writing the equation down above the t with the equal sign there in the middle. So we have x plus 4 equals negative 3. And in order to do that, we're going to model using some manipulatives. So we're going to start out and we're going to identify what each manipulative piece is equal to. We have some green and red long rectangles, and we have some yellow and red small squares. We're going to identify the green long rectangle as an x, the red long rectangle as a minus x. In other words, positive x, negative x. We're going to define the yellow square as a positive 1. We're going to define the red square as a negative 1. So we're going to use these items or these manipulatives in order to model our original problem, which was x plus 4 equals negative 3. So to begin with, we're going to model x, which we said was a green long rectangle, and a positive 4. Okay? So that means I'm going to put 4 yellow tiles here. So then I have modeled x plus 4 on the left-hand side. On the right-hand side, I need negative 3, and the negatives, we remember, are the red ones. So we're going to place that there. Now, we have modeled x plus 4 equal negative 3. Now, the second concept that we need to understand, besides the fact of what each manipulative is the concept of a zero pair. Okay? A zero pair is what it takes to make 0. For example, if I have a red square and a yellow square, that's a 0 pair because I have a positive 1 and a negative 1, which gives me 0. Another way of thinking about that is I give someone 1, I take that away, they have nothing. So in order to solve an equation, we're going to be trying to identify 0 pairs. So if we use that concept with what we already have, basically I want to get this x, or this rectangle, all by itself so that I can identify what one of those rectangles, the value of it is. So in order to do that, I need to make 0 pairs in order to get rid of all of these yellow squares. So to that left-hand side, I'm going to add 4 red squares, because if I do that, then I have a 0 pair here, one here, one here, and one here. So all of these go away. Now, we remember that with an equation, it has to be balanced. So what we do to one side, we have to do to the other. So I added 4 red tiles. So on the right-hand side of the equation, I'm also going to add 4 red tiles. Okay? Now, so in the next step, I'm going to look at, and I'm going to say, all right, on the left-hand side now, I have 0 pairs, so that's like having nothing there. So I can take all of these zeros away. Each of those pairs I can take away because they represent 0. So now those are no longer there. So now what I have is that the value of this green bar, or x, is equal to 1, 2, 3, 4, 5, 6, 7. So if I write this as a number sentence and go back to looking at like this as an equation, I have the value of this, which is an x, equals 1, 2, 3, 4, 5, 6, 7, but since they're red, it's negative. Okay, so by using my manipulatives, I identify that x equals negative 7. So let's see if that's correct. If I have x plus 4 equals negative 3, then remember I can always check my problem by substituting in the value of x for that x in the equation, and then I have negative 7 plus 4 equals negative 3. And remember that when the signs are the same, we add. When they're different, we subtract. So on the left-hand side here, a negative 7 and a positive 4, the signs are different, so we're going to subtract and get 3. And when we add and subtract, remember the answer is always the sign of the larger number, or 7 sign, which is negative. And I actually do get negative 3. So my problem does check. So that would be correct. Now, another way to solve this problem, which is very similar to this, not using a concrete model, but using addition or subtraction, would be to start out with the same equation, which would be x plus 4 equals negative 3. Now, remember what we did with the manipulatives. We added negative 4 to both sides. In other words, we added 4 red tiles, square tiles. So that was negative 4. Okay, and what we did to one side, we had to do to the other. So then negative 4 is equal to negative 4, so I can add these things because they're equal. And then positive 4 and negative 4 gives me 0. And on the left-hand side, I have x. On the right-hand side, the signs are the same, so we're going to add and get 7. Sign of the big number is negative, so my answer is negative. So x equals negative 7. So as you can see, when you use the subtraction property of equality to solve the equation, it looks very much like the steps that you use when you solve using the manipulative.